Recording has started. Let everyone know they're being recorded.
There we
All
go.
right.
All right.
Thank you.
Okay.
Appreciate
My
that.
pleasure. My pleasure. So we did two different analyses for you. We did one based on the number 16 pond using 12 fairway and 15 fairway.
Mm-hmm.
And then we did another one, which is, I can get this right, 9 pond, 9 fairway, and 18 fairway. Okay.
Okay.
That making sense?
It does.
All right. Don't try and make sense of this yet until I explain it to you. So what you see here, you're accustomed to seeing a standard water analysis.
Mhm.
I'm laying it horizontal.
Okay.
I'm not going to put that on one sheet because what I want to do, I want to lay the water out horizontal and take those elements. And then I want to put not available, not exchangeable. I want to put total soil properties beneath that. Then what I want to show is I'm going to take that water. Now it may be just your irrigation water. It may be your irrigation water with treatment. It may be your irrigation water with treatment spiked with my material. Okay. Or maybe just your irrigation water spiked with my material. And I'm gonna wash that through your soil, which is kind of an exchangeable, it's an available soil nutrition analysis, but I changed that because I increased the amount of water to soil and I have a longer soak time. And I don't use lab water.
Mm-hmm.
Okay. I'll use your water or your treated water or your water, however you want to give it to me with my reagent in it.
Gotcha.
And then that's really giving me a better picture of what my plant's getting to drink. Okay. Now I've verified all this with dozens and dozens and dozens of analyses. And I did that in conjunction with a guy named Denny Barron, Robert Opold, who was with Istrict, and Dr. Dave York at Tournament Turf Laboratories. Okay. And so what we found was happening in your world, in the superintendent's world, is they would see this available nutrition analysis and see deficiencies in the nutrients, so they'd add them. You with me?
Yep.
Yet we had a boatload in the soil. So what happens when we put too much nutrition in a filter that is on top of more nutrition and on top, the filter basically gets plugged.
Mm-hmm.
And water, which we won't swim in because it's kind of septic, we'll put out in the sprinklers and we'll play in it, but it's still septic. It just looks cleaner and clearer, right? And then that winds up in our soils, and we now have a soil which is like a pool made out of dirt. And you can imagine what it's going to do, right?
Mm-hmm.
Hence, we see black layer, we see iron layers, we see iron bacteria, we see scale formation, etc. Okay. So what I've done here is I took your pond, 9 pond water, and I just threw out the numbers. The pH is 8.5, which means there's no real nutritional value at that pH, right?
And that was after a big rain, by the way.
Yeah. And then, we got a little bit of calcium, a teeny bitty type amount of magnesium, a little bit of potassium, no phosphorus. Okay. We got a boatload of bicarbonate. All right. So people say bicarbonate's a problem. Well, it is and it isn't. It's not a problem with your water because you got no hardness for it to form scale with. But what hardness you do have there, if you evaporate it to dryness, will form scale because there's bicarbonate.
Okay.
So let me put that in perspective. If you take calcium carbonate and you put it in acid with water, it releases the gases, which is the bicarbonate, and then the calcium goes into solution, right?
Mm-hmm.
Okay, which builds EC and TDS, right? And that's all great and drinkable. But when it evaporates to dryness again, it reabsorbs the bicarbonate, and it actually forms a denser calcium carbonate than it was initially. And so it starts accumulating in the soil. Now, here's my proof. Here's my proof to you. You see this number right here? 102,400. That's
Yes.
parts per million of calcium that you have in Fairway 9. Hold on, let me make that even more shocking. That's 278,467 pounds per acre of calcium. You can't call that
Wow.
soil. You call that concrete or mortar. I don't care, whichever one you want to call it.
Yeah.
Okay?
Wow. That's.
Answers a question, right? I can't get a probe in the ground. Yeah, you can't because it's mortar. Mortar's
Yeah.
not designed for a probe, right? It's not designed for a jackhammer. Okay. And this is chronic in the industry. This isn't you. This is agronomy. Okay.
Mhm.
Granted that's pretty bad. Okay. Compared to stuff I've seen, but I've seen a lot of bad stuff. Okay.
Mhm.
And it's chronic in the industry because you also have 13,000 pounds per acre of magnesium, 10,000 pounds per acre of potassium, 2,744 pounds per acre of phosphorus. And yet the available nutrition analysis says, oh, you're short on phosphorus. No, I'm not. No, I'm not. I need to move it from the soil into a solution that the plant can drink to reduce it in the soil. So that's what pH does. You lower the pH, the plant drinks it, it's happy. But with sulfuric acid or sulfurous acids, what would happen is what the plant didn't drink accumulated in the soil into a denser crystal that the acid then wouldn't break down. So third year, you're pulling your hair out. Fourth year, you're looking for a job, right? Or the reason that tines won't go in the ground, right? These are the reasons.
Gotcha. Yeah.
All right. So it's not you, it's agronomy. That's just the way it is. And so when I met this PhD that helped me identify this, he goes, well, I have to put calcium on because my plants need calcium. Yeah, but you can't. What you need to do is you need to make your water a better solvent to break that calcium down so your plants drink it, not put more on. Right? You're going to fail an ISTRIC or a USGA analysis, right? Because you're not going to have infiltration rate. You're not going to have infiltration depth. You're going to hold water. It's going to go septic because you got all the food source for the different bacterias, and they're going to go crazy. They're going to love this muck.
So I have a quick question on that, right? So say we're doing what you're doing in the industry. We're saying, hey, we need calcium. Our base saturation and soil test shows that the base saturation is completely off, not where we would want it.
Horrible test. Horrible test.
Yeah. So you throw more calcium. So right now, there are totes out there of it's a 2300, 5 calcium, 1 magnesium. So if we have high bicarbonate and we have high carbonate levels and we're throwing calcium out there, are we forming insoluble lime? Is that calcite?
Absolutely.
Now we're having that concrete layer on the surface.
It's accumulating.
Yeah. Okay.
Right. But it's the right juice. You're doing the right thing. And let me show you why. Okay. Because when you go over here to your computed sodium percentage of your water, look, it's 99% readily available, drinkable sodium. So computed sodium is calcium, magnesium, and potassium in comparison to sodium. You're 99% salt water. So you're adding the calcium, which you should be doing, because you got to get that below 40%. So you're adding the calcium, but the problem is what your plant doesn't drink then accumulates in the soil. So you're making mortar, right? Add a little glue, add some paint, it'll look beautiful. Right? Right. So what we would do, we'd still add this, but why would I add these nutrients that I need to lower that sodium percentage when it's all in the soil and I can just release it from the soil? Look at what my computed sodium percentage did right here when I liberated it completely. Went down to 3%.
Wow.
And I could probably do that for about 3 years with the amount you have. Okay?
Wow.
So then I took your water and I ran it through the soil in this enhanced test, more water, less soil, longer soak period. and I got it down to 84%. That's not enough. I got to get it down to 40. Okay. So you and probably when you get a rain, you go like, wow, I'm flushing salts. No, fact is you're not flushing salts. You didn't flush salts. You got to push a growth.
That would be evident on this test because Brad and I, when we pulled, we had just got what, couple inches of rain the day before, right, Brad?
Yes, and
So
it had
this
been
is a
raining and it had been raining. We were averaging every 7 to 10 days, 1.5 to 2 inches of rain.
Right. So here's what happens. You get this flush of growth and you go, wow, man, I'm flushing some salts. You're really not. Here's what's happening. You're getting pure water. You're getting oxygen that it picks up on its way down. And then that oxygenates the nitrogen that turns it to nitrate. So you just drank a Monster Energy drink. No big deal. But when you're done drinking that Monster Energy drink, what happens afterward? Now you're drinking sodium, not calcium, not iron, not potassium, none of the good stuff. Okay. That's the crash. So I'm going to make your water actually better than rain and better than acid, because I'm going to dissolve these things by increasing the ionization potential of water by adding an acid. And when I convert them and when I release the bicarbonate and break apart the chloride and break apart the natural bonds that exist through a term called valence, the attraction of an anion and cation, they're going to be in an ionic form that they will always rehydrate. They will never complex again. So now the marbles in these middle rows are going to start reducing, because what did I do? I started moving them into available nutrition. You follow me?
Yes.
And while I'm doing that, I'm cleaning this filter, right? By putting the nutrition back where it came from. And while I'm cleaning it, what am I doing? I'm making pore space. I'm dissolving crystals. Water starts going down, right? That's how it works. That's what it does. You've got a lot of lime, and no wonder you do. You had to. It's probably your only salvation. Not a lot of people have lime, free lime. Okay. But so you've been fighting. I mean, you've been fighting the tail end of the end of the string of agronomy. Okay. In my opinion. All right.
Right.
And it's a monster. Yeah, it is a monster, but we can fix that. We can change your world.
Awesome.
Okay. Then this sheet is pretty cool because what I can do. So here's what it's going to require. I say, because of your soil, well, your water requires 2 gallons of my acid per million gallons of water. 2 gallons. Okay. It also requires 1 gallon of my biocide, my antiseptic.
Okay.
Okay. I'm going to recommend you double the acid for probably 12 months. 4 gallons. Okay. And I'm going to say you throw in another 0.5 gallon per million gallons of the biocide. We've got to get this cement broken down.
Yeah.
Okay. And so you're going to start seeing water go down. You're going to see infiltration depth. You're going to see vibrant turf, because now it's getting the nutrients with the sodium. The sodium percentage is down. The beneficial metals and minerals are up. I'm going to be adding oxygen with that biocide. I'm going to be breaking down biomatter. I'm going to be killing, if you've got soggy areas or where you're holding water and all that, that's going to change. Okay. And
got a lot of that.
Yep. And a lot of that is cementation that then goes septic. So you got to treat the septic before you can deal with the cementation. And most of the cementation isn't there anymore because the freaking black layer produces sulfuric acid.
Right.
Yeah. So I throw in here my cost per gallon of my acid in totes, a biocide in drums. I go and tell you I'm going to reduce your water demand 15%. 15%. And probably more.
That's
Horseshoe
fantastic.
Bay, I reduced it 40%.
Wow.
And the other 2 courses actually used more water than they budgeted for that didn't have my material. Bear with me. I want to do something here. So I'm going to put up in here, which I can do for you and you can do on your own. Say 1 acre, 1 million gallons of water. So it goes down here and it says, all right, for 12-month period at these 12-month rates, which is double. Okay. I'm going to spend, it's going to cost you $265 per million gallons of water,
Mhm.
which is a lot of
And
money.
and then we can consider the water amount savings too.
Well, I factored it in right there.
Okay, gotcha.
And if I take that away, those numbers are going to change.
Understood.
Okay.
Oh, that's great
So
that's already factored in.
there's a lot of years in this sheet. and then on the annual program, okay, it goes down to $151 per million gallons of water.
Mm-hmm. Wow.
Okay.
Yeah.
And then, but here's a big deal that a lot of people don't realize. And let me just open up another sheet.
Okay.
If I can get to it easily. Sorry, I should have had this open for you.
No.
Time is money, and you can't buy any more of that, right?
No worries.
So I have James, I think you have this sheet. It's an end
Yeah, I
user
think
pricing
so.
list.
Might not be. It might. Yeah, I think I have one from the fall.
Okay.
I'm not sure if you changed anything.
So I kind of want to reverse this sheet because this is an end user pricing list of our materials. Okay. So I can go, okay, well, I'm going to, buy a tote and I'm going to buy a drum and blah, blah, blah. And I'm going to buy a chemigation system, et cetera. But here's the offsets. Here's the money I'm going to save you. Okay.
Mm-hmm.
You can put a value on any one of these things. Okay. And if I put the value first, you say, wow, so he's telling me he could save me $30,000. What's it going to cost? I'm going to cost you $35,000. So my program costs you $5,000.
Mm-hmm.
But people don't look at it that way because they say, all right, I'm budgeted for all this stuff, but you're not going to buy all that stuff.
Mm-hmm.
Okay. So you can lay your own numbers in here and then it'll show you what that program is going to cost you. So take out one aerification and top dressing and the replacement of broken tines. How much is that going to save you?
Oh, yeah.
Probably the cost of my entire program, including chemigation.
Right.
Yeah. It's that crazy.
Yeah. Well, if you can save one greens aerification, that's a large number.
Wow.
That generates revenue
Wow.
anyways.
And that goes away. Most of my customers will tell you they've never had better greens ever. I mean, from Horseshoe Bay to Oklahoma to Florida to New Jersey, it's all about that soil health and available nutrition.
Yeah.
Yeah. So,
well,
and I could share this with you as well.
Brad talked to Charles.
Oh, you talked to Charles. Okay.
Yeah.
So
did we go over the part where you've run it through already?
No.
Oh, okay.
No. So I just took your water and ran it through, right?
Yeah.
And so pH is 8, which is, it's okay, but not in conventional agronomy. It's not. Okay. And we got some minerals, which is great. We got some lime, which is great, but my sodium's through the roof. Okay. And my sodium percentage, I'm still toxic. Sicker than a dog. You put that much sodium on your steak and your wife's going to kick your butt.
Very true. That's the truth.
Yeah. So, and let's take a look at biology. So you got 4 colony forming units, 4 exponents of bacteria. So here's your bacteria right there. Okay. So that's requiring that we have to deal with that bacteria in the water, and the food source that you have for bacteria is pretty massive. You've got all the sulfur and sulfate, you got all the iron, you got all the manganese. Okay, that's the perfect food amount and volume for sulfate reducing bacteria, black layer, and for iron bacteria. Now, it's not the bacteria that cause the problem, it's what they produce. So their waste, iron bacteria is biofilm, polysaccharide. So it's that iron slime. And then sulfate reducing bacteria is fed by sulfur, but its waste product is the sulfurous acid, hydrogen sulfide gas, the smell. Okay. And then they both produce water. Okay. And so you've got to have the antiseptic to start knocking those colonies down. So consider bacteria problems in soils and infection. And you got to get the bacteria count down until what you're doing agronomically can take over. Okay.
It'll just continue to further deplete our oxygen levels, and
that's right. That's
the areas,
and it'll grow. It grows exponentially, right? Like every 15 minutes, it can double in population, especially when it's warm, and then it can go dormant and cold. Fire it back up, they're all there again. Nobody left the party. They're just ready to party again. Okay. That brings me to another picture I would like to show you.
Okay.
So this was kind of we've had a lot of eye-opening things happen over the last year. This is one of them. So we got a sample of some material out of San Diego, and I mean, it was nasty water. One of the first times I ever put gloves on and a respirator. It was black, it had sludge. So I split it up into 3 beakers, and I completely acidified one sample, and it left matter. This is my acid. It's tough stuff. My acid is amazing. Okay. Then I said, all right, well, I'm going to throw it into the antiseptic and nuke it, right? As much antiseptic and water as I could, and it left matter. I said, all right, I'm going to throw it into both my acid and my antiseptic. Look what I got. EC.
Wow.
So I can move all that stuff through a green in a heartbeat.
Yeah.
We could do it overnight if you want to.
That's amazing.
It's a lot of juice, but
Yeah.
bacteria live in minerals and metals and soil, right? And then they do their exudates. And so if you go after the minerals and metals to free them up as food source, it can't even get through the bio. So you got to get through the bio in order to get to the scale. And sometimes you got to get through the scale and you'll hit bio. Then you got to get through the bio to get to the rest of the scale. So this is one of the reasons this stuff works.
Wow.
Yeah, we got all, there's a sponge cake out of Florida. We cleaned all that up in a heartbeat. And there's another one. We did a test with Robert Opold right there. That was 12 days. Every other day for 12 days, we put a gallon of material on this soil of diluted material. Okay. And look at how much black layer we moved.
Wow.
You can't do that with aerification.
That's incredible.
Isn't it?
Yeah.
That's 12 days. So I'm going to have your water do it continuously throughout the entire soil profile.
Yeah, that's incredible. So we have, for example, out here, as I've learned the property and started wrapping my head around everything, we have last year, after the hot summer, we got a lot of rain in the fall. The fall was warm. We could have been driving some roots on the champion greens. So, and this is considering a lot of rainfall, by the way, too. Well, through the winter time after that, I started probing the greens, and we've got 1.5 inch, 1 to 2 inches of roots. So here we are, as we're trying to wake up, and we're going into how can we drive roots, knowing that we have the conditions and the water that we have. With aerification coming up, referencing what you just said, if we're able to remediate black layer, if we're able to start freeing things up and we're able to start driving roots, because I don't see the greens really being in a position to want to be aerified right now. I'm frankly worried about aerification. Last year, the property was aerified in April, and I was told that it was flat out miserable for months. They almost didn't heal.
But look what's happening when you do aerification. Okay, we're thinking aerification, we're oxygen, pore space, etc. What do we fill the hole with?
Yeah,
salt water.
Right.
Right. Even though you supplement it, still, and it's what? Even if you do a 1-inch core, you still got 4-inch square. Right? Yeah.
Right.
Yeah.
Yeah.
This will change your game. There's no question about it. You can call Ray Gomez over at Horseshoe Bay too, and Stuart Rowland at I can't say the name of that place. Cordillera. Ryan Kaufman's been on it at Wild Horse Pass for, I think he's going on his 5th year.
I think so. I think you're right.
Yeah. I got about 230 courses across the country.
Awesome. Yeah, I feel like it's something that we need to be on. Already got some estimates from James for the infrastructure, so we're already one step ahead of already budgeted for the infrastructure. So I really appreciate all this information because you're bringing more of a clarity to it. Can you explain?
Well, and what's cool is it's supported by the numbers, right?
Right.
And I earlier on, well, late last year, I say, wow, I get to sit behind a desk and see this stuff. It's cool. Right. And write a prescription and patient gets well. How cool. Don't even have to go to the site, right? Sit here and drink beer.
Can you explain what happens to the sodium in the soil as the acid is battling it and going through the chemistry, so that the sodium is not available to the plant, yet the plant is becoming in a healthier state?
That's a really, really good question. So 2 things happen. One is if you create infiltration depth, right? You move it out of the root zone. It's the most soluble salt, right? It's the most soluble thing on here, except nitrogen, oxygen, and pure water. So we move it out of the root zone. The second thing is I protonate it. I chemically protonate it. I'll tell you how I do it, but it's a $30 million check. It's you add a proton to the free electron of the sodium, and it's inert. So I can run 1,000 ppm of sodium and chloride through tissue, and it'll still be the best tissue you ever saw. It's inert. In fact, years ago, when I first got into this, there was a pile of white powder, and the guy's going, look at the calcium you moved. I go, I don't think that's calcium. He goes, no, it's calcium. And I went, pure salt. Pure salt. Yeah, not calcium.
So it's being moved and it's unavailable for plant uptake.
No, it's available for plant uptake. It's just not damaging.
Oh, okay.
So it's inert. It's like drinking NA beer, right?
Yeah. Okay.
Same thing. It just doesn't have the capacity to cause damage. No tip burn, no nothing.
Wow.
Yeah.
Okay.
Yeah. Right now, there's something that I say about when you take samples. I warn people about confining layers. So if you always, tine the greens at 6 inches or 8 inches, for year over year over year, and then you filled those holes again, odds are you accumulated a confining layer at that 8-inch depth, right? And over time, you'd go and do a core sample. Istra could come in and do a core sample, go, yeah, you got this one layer right here in tier 2 that's, really bad, but they never looked at the chemistry of it, right? They just looked at the physical properties of it. So we do that in agriculture. And sometimes we have to look at it in greens too, right? But I'm putting sweet water down all the time. That water's healthy and fixing soils. It's just I need to modify it sometimes. If I finally get water into a confining layer that I identified and it's loaded with sodium and chloride, I may want to add a little more of actually another juice, which is our concentrate material that doesn't have any acid or any peroxide in it, just to add more of that protonation chemistry.
Okay.
That cool?
So we have, yeah, very cool. Very. So we're going to, the plan here, and somewhat of a combination of everything that I'm going to explain, is the product that your product here that we're talking about is basically at our base level. It's required, it's needed for us to be able to grow some turf out here. We are on top of a lot of clay, and in that clay, we also, with a lot of the rivers and creeks that we have going through, we have some aggregate, some large aggregate. We do have some caliche. So we have been unavailable in the past. I've been told to aerify the property, which is obviously, we've talked about that, and it's expected that we should not be able to aerify the property with the problem that we have. So we have had really good results.
I don't think it's your best solution.
Yeah, right. We've had good results with a piece of equipment called a shockwave. And so we've
fracking.
been able to, we've been able to get about 6.5 to 7 inches deep on the most compacted areas of the course on the first pass with the machine.
Right.
So as we create that channel, we're going to be top dressing with some new topsoil or some more of a sand-based profile. So as we're using your product here and we're flushing it through the soil, and that's going to help us drive the salts even quicker.
Yes.
What's the relationship then for us to be able to use some of our other pumps to get some humate in or some humic acid in and try to get this biome reactivated out here?
Well, we're going to do that. We're going to do that too. If you want to put some humic or fulvic or something like that, you can. I'm not saying you need it.
Okay.
So, let's go back to your sheet. I want to show you one quick image here.
Okay.
I think I hit the right one. Where am I? Oh, sorry. I goofed. Through the best looking grass you ever saw on that clay.
Mm-hmm.
You'd say there's no pore space there, right?
Yeah, I just washed all that off my shoes before the meeting.
Right. But it'll so the reality is, if it has moisture, then it can hold EC, which is what moisture is, and EC is drinkable. I make EC, soluble salts. Okay. And that course is, here's another one. It's not the same course, but that's on really rough water.
Wow.
I can show you another one where I told the guy I wouldn't wash a buffalo with his water because the buffalo would be dirtier. So I understand what you're saying. I know Troon's all over the fracking, and I think they own their own equipment. And Kemper probably as well. This is that clay soil, by the way.
Wow.
Okay, and that's on rock granite. That's a University of Arizona course. And look, you can see the cores. Oops.
Yeah.
See those cores solid? I mean, just solid like clay. There's a worm right there. They've never been able to have striped fairways ever.
Wow.
And they're one of our first clients. But so I like fracking. Okay. But understand you're opening soils. Okay. But you're not fixing soils. So similar to core aerifying, you're opening soils, right? But you're not fixing. So you make more pore space. Well, great. But my turf is all about what is drinking.
Right.
So if I don't fix the water to what it's drinking, so it's getting that perfect Monster Energy drink, I don't care what, I really don't care what I do to the soil. I don't, because it's what my plant is drinking, which is important. And right now, your filter is dirty, and so okay, you go and break it up and crack it up and put it back on. You only have these fissures for air to come through, right? You only have fissures for nutrition to go through, but the roots, you want them everywhere, right? That's the point.
Yeah.
You've got to break down the concrete, the iron, the nutrition, and make it available for the plant to drink. You need to reduce that quantity. You could physically reduce it, but you're still not releasing, making available nutrition. You're just physically reducing the amount of concrete that's there and replacing it with sand, and then putting on challenging water, which in turn, you're going to load more of what you've been trying to remove in order to make that water beneficial. So it's not a sustainable situation.
Right. Yeah.
I know that's a lot of moving parts, but that's my mind. That's how it goes.
Yeah. No, it makes sense what you're saying. Yeah. Yeah. The HCT and the irrigation, that's our base. That's our model. That dictates everything. And then anything that we do after that, which would be just beneficial golf course practices, they'll amplify.
Exactly right. Yeah, we're not going to remove compaction, right? The odds are, if we're doing everything right, then odds are the amount of aerification that we would do would be dramatically less, because maybe there is a matter of bulk density that we want to reduce because of silt or things that we can't break down. Like silica. I mean, I actually can dissolve silica, but yeah.
Awesome.
Did you go over the after you put the acid into the run it through the soil, what the result was afterwards? Did we do that test?
Yeah, that's yes, the available soil nutrition analysis, this last one. We talked about the pH was 8, and we were liberating the minerals.
And that's where that was treated, right?
Yeah.
Okay.
Yeah.
When
well,
treated.
no, we didn't. This was just your water.
Okay. All right.
I think it was just your water, and you had free lime, which helped you out immensely, but your sodium was still super high, which in turn, and people normally don't put this on analyses. Look at the percent of sodium that your plant is drinking. That's the problem. And I don't know, you could probably run your same program and incorporate my base chemistry and detoxify that sodium and not have an issue. But you're not going to fix the soils. You're not going to fix this problem. And you could aerify a whole bunch and start physically removing that to fix it. But I got a better solution. Let's move it into available nutrition. You bought and paid for it. Let's consume it.
So that one below that you're working on right now, that's treated, right? You've taken his water, you've added your products to it, and he's at 84.
I don't think we added our product to it. It's ASNCW. No, it's just his water. Client water, CW.
Okay.
I don't think we didn't spike it. If we did spike it, these numbers would come up, right? These numbers would not change. These numbers would come up. Okay, so we'll liberate more sulfur, sulfate, iron, manganese, etc., and these numbers come down.
Yeah, and that's the two I was looking at, the 84 and 91%. I was wondering if we had the results from the HCT spike.
Right. If we did spike it and it was still high, then that's where this number comes in. Right there. We'd add more product. Because that product primarily is going to react with the minerals and the metals.
Gotcha.
What would you estimate that's the sodium levels would go down to spiked? Had 40, 50?
Well, I don't think that they really go down. What happens is you increase the mineral and metal content, so the percentage goes down, but the marbles don't move, right?
Thanks.
Yeah, the ions are still there. Now, when you start restoring infiltration, then the percentage in that root zone goes down because you've moved them through the soil profile. But right now, the reason that sodium is in this category, so you see up here this little category,
Mm-hmm.
because when you have chloride, which you don't have a lot of chloride, but chloride is like bicarbonate is to calcium, chloride is to sodium, zinc, and boron. You also hear a potassium chloride, right? Chloride's a glue also. And so up here it says chloride also locks up iron, calcium, zinc, potassium, phosphorus, and boron, but also it'll harbor sodium. So when you water, everything stays locked up except that darn sodium. That sodium just goes right into solution.
And then the sodium toxicity, if it was spiked, where would you?
I can't measure it.
Yeah. Okay.
Right? I can only demonstrate it. Well, you could take a tissue and say, oh, this was untreated, this one's treated.
Yeah.
The treated one's got massive amounts of sodium chloride, looks like $1 million and it's 3 times the size. Well, not, it's 30% bigger. Or the other ones, cooked at the ends, etc.
What was the other sample? This was just one, right?
Hold on, I want to save that. Oops. Back to 16 pond. Right, there you are. All right. So here's 16 pond. Wasn't much difference. But it's pretty much the same. What's going on here? Hold on a minute. Something's wrong. I know what happened.
There we go.
Somebody hit that to a number instead of a percentage. I'll take the blame.
So similar, looking at, what is that? AO on the columns there, where you got the sodium toxicity, and U, I guess it's U on the spreadsheet. Go to the right. Yeah.
Go to the right.
Yeah, right there. That's the sodium toxicity.
Yeah.
That's where I was trying to go with the whole time. Like, if this is where it's at now, what's it like when you're treating?
Right. If I treated your water, so spiking is just a hypothetical, because I'm just taking a certain amount of my material to an unknown water and unknown soil and throwing it in, right?
Mm-hmm.
But I can show you examples of that if you want to, but we didn't do it. But what I can tell you is what's going to happen is, all these minerals are going to come up. Okay. The metals, which don't factor into this equation, are going to come up. They should factor into that equation, but they don't. Okay. But basically, these numbers come up, these three numbers: calcium, magnesium, potassium, which then reduces the percentage of sodium. And I've got to have these, you need to have these numbers. You need to have this number in your soil, what your plant's drinking, at 40% or lower. And even though you're adding the lime, what's the go-to thing they say? Oh, you got sodium issues, then you need to add calcium or free lime, right? Well, you can't. Look at this. You can't. I mean, you have to, but you're eventually going to kill your soils.
Mm-hmm.
You'll seal them off.
So it's making those numbers on the bottom a more desirable ratio while treating the soil and detoxing the soil, like you were explaining before.
Yeah, there's a lot of reactions going on, right? So you're increasing the available mineral and metal nutrients, right? You're dealing with any of the bioexudates with the biocide, and you're adding oxygen. At the same time, you're reducing the amount of sodium your plant's drinking because you liberated all the other things to make it as available as sodium.
Mm-hmm.
And then your sodium's going to fall through the soil profile.
Yep.
And then your watering practices will change. So initially, you want to get a lot of product out. I mean, if you buy a tote, why, and it's going to last you 3 months, why not get half of it out in the first couple of weeks, right? Let's get the soils opened up. And then let's wean out the rest of the product. Make sense?
Yeah.
Yeah.
Yeah. Yeah. I was going to ask if we can do that, if we can, throw out a higher dosage, go curative with it, and
Absolutely.
then start backing off to maintenance levels.
Absolutely. We could easily do this. I mean, you can put this stuff out at some pretty crazy rates. So we go 4, 1, 6. Numbers didn't change. Time did. The rate of the reaction did.
Yeah.
Yeah.
And you're almost, well, every single time somebody put out a mass amount of chemistry for whatever reason, the line is, man, we never baled so much hay in all our life.
That was going to be a question, and I just to double check. So say we go curative with it, throw a high rate, referencing the black layer pictures you showed in the profile that you drove and cured in the greens. So you're just liberating the turf. There's not
right. Liberating the minerals and metals from the soil for the plant to drink.
Gotcha.
Yeah.
Awesome.
And the what else was I thinking? So you'll also run into situations where you have these chronic areas. So these chronic areas are usually where water has accumulated, or they rebuilt over an area where water used to accumulate. Now you got whatever was down there coming through. So that's why we developed these little topical products. But from your pump station, if you go with the chemigation system, you could go and change the numbers and then fill your sprayer. Okay. And then go and spray those topical areas, because they need more medicine. They got more minerals, more metals, more biology. Okay. So they need more. Gradually, you're going to have uniformity across the whole platform.
That's the fix, right?
Yeah. The fix and the grow. Grow's designed more for the biological, the wet, soggy, yucky, and then fixes for the more calcareous areas. So maybe you have an area that's calcareous, you'd want to spray it with more of the curative, but you still want a little bit of the BC there. Okay. But you got an area that's already anoxic and yuck, etc. You want to mainly focus, that's the grow product, which is mainly the biocide. But you still want a bit of that curative, because those pictures I showed you, those beakers, right? Yeah. You need both.
Gotcha.
Yeah. Okay. So you got the BC, you got the curative, and the fix for the spot treatments, Brad.
Yeah. You can, and you can make the fixer grow too out of the concentrates.
Okay. So as we implement our recipe for Iron Horse, and as we go through it and as we start seeing some things, we can continue to touch base and say, okay, hey, I got a couple of problem areas, and we can kind of hone in on some different areas and continue to get your expertise as we go through this and develop the plan.
Yeah, it's really, I mean, it really sounds complicated, but it really isn't.
Yeah.
Okay. And you'll get a feel for it, but it takes a while to get the feel for it.
Okay.
But yeah, I mean, and we can rerun this data. So, we want to run this data through your soil with the treated water, right? And see what we have. Right. And I don't want to add fertilizer if I've already got all this calcium, potassium, phosphorus, etc. I don't want to add more. I want to release more. If it's not getting down here, I want to just make my water hotter to bring it out of here and move it into the available zone. Eventually, this is probably the first one that you're going to replenish will be your phosphorus.
So this can be our base. This can be our baseline testing.
Oh, it is.
And then we move forward, what would you say in about a year, do it again and compare the two?
Yeah, well, so you're moving along 3 months down the road. Maybe you're concerned about something, then we'll run a test, right? Or maybe things are going great, go, nah, no worry. Or maybe your water quality changed some drastic, concerning way. You had a bunch of snow and they threw a bunch of salt and it all wound up in your pond. And so you want to relook and adjust. Okay. But yeah, this spreadsheet, I'm going to show you something. We can add rows and rows and rows and just trend it, right? I just opened it up is all.
Okay.
Yeah, that's pretty much it.
Awesome.
It's kind of cool.
Yeah, it's cool.
Kind of gives us a throttle, right?
Yeah.
It shows you that what we were taught, although it might have worked in certain areas, but you start building up that sulfate, the gypsum, you know, it's not doing you any good. It's just adding up there, staying there, right? That's what we were taught. Got sodium, throw gypsum, throw limestone, So that's what we were all taught in school. It's probably in the books right behind me,
Yep.
Yep.
And another thing that shows me you've been fighting the war is the amount of nitrogen that's in the soil. Living on calcium nitrate, right? Monster Energy drink, maybe with a little caffeine.
And Brad,
and like daily, right? It's like, yeah.
You've talked to a couple guys already, or you've talked to a couple, Charles is a good point of reference, and, having those guys tell you, like, for me, it's been valuable for Charles to tell me what he's seeing, because he started about this time last year. I think they got their pumps right about now. So they started injecting. Yeah. And we've, you and I have talked about it. They used to use hammers to put the stakes in the ground at Windstar, couldn't get a T in the ground. Well, it seems like it's changing, So yeah, you want to run the test again? We can run the test again at some point. You've got the quotes on the equipment. Todd's spent his time here with us today, which I appreciate because it's all over my head. So
no, we've got everything that we need. And then will I have these? So like I said, Doug, general manager, he's on he's at the leadership conference, but he knows that we're filming. I'm going to send this to him. And when he comes back, we're going to talk about this. The client, the city of North Richland Hills, knows that this is huge for us. So we've already done a lot of the legwork in regards to the infrastructure and talking to them about the investment that the product requires. So really, this is just the finality of some of those conversations on our side. So so I'll get this to Doug, and then those spreadsheets show our prices, our rates, and I think that we're going to be planning on moving forward. Really, my plan is to move forward before the start of the next growing season, so that as we go through the next growing season, we're going through it with HCT.
Well, there's no better time than to get solvent water out there and start breaking up some of those nutrients. So when you wake up, you got breakfast next to the bed, right? Yeah. Coffee and eggs, ready to go.
Yeah, that was my planning with it. So the planning for me, I don't think could be better. We can start this next growing season, and by the time the end of the growing season is here, we should start to see, hey, this is now the direction that our property is going. So
yeah, you'll see it pretty quick, especially if we move those numbers and double up on the chemistry. I mean, you're going to
Mhm.
invest, put it out, right?
Right.
Right.
Yeah.
Put it out, get the soils working. I don't know, I forgot what I was going to say. So we got the audio. I'm going to send you the spreadsheets. I put in 1 million gallons. Oh, so on that pricing list that showed all the savings, and
Yes.
when you go into budget and go like, hypothesis says we're not going to spend this money on this and this money on that and this money on this and this money on that. We're going to put it all here because we won't need to spend it there. And
Mhm.
really, they come out ahead financially.
Yeah.
It's crazy. And then you've got
Yeah.
people who will tell you, horse thief and Charles and all that, they say the amount of money they're saving is redonkulous. Charles is going to replace what, 6 trees? He'd been fighting for 3 years and now he ain't replacing them.
Yeah, it comes
Right,
to
James?
it's just some of the random other things for sure.
Yeah.
Yeah.
So,
You'll see it. Like if you get the same results as Ryan and Charles, you'll see the difference. Like you won't be spending time doing things. Your irrigation guy is going to be faster at his job because he can dig. It's things that all add up, right? So
yeah.
yeah. So,
Yeah. Take your broken time budget and throw that over our way.
Yeah. There you go.
it's like you put sod down and the sod dies because you're just putting bad water back on top of it, right?
Right.
You spent the time to replace the sod. Looks great for a little while because you disrupted the soil, you got some infiltration there and it's moving, but then it just goes back the way it was and it dies again. So
Yeah.
those are probably the savings you're gonna to realize, long term that you can't really put a number on right away, So Charles is irrigation tech. I don't know what you guys are doing, but I can dig. Right. Charles's soil was so bad, bro, we couldn't even get a sharpshooter in the ground.
Yeah.
And Charles is a big dude. So, yes. But if you need anything from me, you let me know.
I will. And that's what Charles said. Charles is, he couldn't say enough about it. He gave me all sorts of examples. He's like, the benefits are just, like a multi-chapter book. So, and everything that I was sharing with him, I was talking about our property. And then when I finally was done, he was like, well, that was all the same things that we were seeing. And he was able to go through how every one of those situations, whether it's physical to irrigation to obviously the science, just he's seeing improvements all over the place. So
Yeah.
I'm excited. I'm really excited.
Awesome.
Yeah.
Well, James, thanks for bringing us together.
Yes, sir. My pleasure. Brad, give me a call whenever you get a
appreciate your
chance
time.
to talk to you guys.
Likewise. I appreciate both of your guys' time, your help, and I appreciate all this information. This is awesome. So thanks to both of you.
Thanks,
Ditto,
Brad.
back at you guys.
Thanks, Todd.
All right.
We'll see you.
Have a blessed day and make sure to look both ways.
All right.
Okay. You
Thanks.
too.
Thanks.
Thanks.
Bye.
Bye.
Okay, stop recording. Hey, James. Awesome. No, I think you're right. I will have to relook at it. But I just modified that document today. Okay. Yeah, let me look at what we did and see what we did but moving forward, the form actually has that question on it. I hear you. I had what? I did. No. No. He reached us at GCSAA. I don't know much about him at all. Is he a competitor of yours? All right. Uh-huh. You got it.